Okay, hello. This is a demo video for CHIP3 Zero Coding Oracle Service submission for Venom Hackathon. Our team is called Dipland, and we made an Oracle service, Oracle protocol, that is fully compatible with Venom blockchain and has free market tokenomics, friendly construction of feeds and oracles. And overall, the purpose of our submission is to provide a universal Oracle service where you can firstly create your own Oracle tasks and feeds from pre-made blocks through a constructor without any complex process or knowledge of coding. In fact, it's zero coding Oracle. So you can create any task you want, and it will be executed and will provide answers right from the start. Because a lot of oracles specialize only on price feeds or accept tasks, but they accept them as direct cyclic graphs, and this is not easy programming. So our Oracle is much simpler, much user-friendlier. Also, you can use it for a lot of tasks. Currently supports immediate requests, scheduled requests. Scheduled requests can be made to automate your smart contracts. For example, if you want to call something monthly or daily, and you can make immediate requests, and you can make price feeds that work constantly. Next, what we want to do with our submission is to provide free market tokenomics. A tokenomics where every participant of this system, of this protocol, is not dependent on some single centralized entity. So for example, you can start your own validator just with having a node and with staking enough tokens. You don't need to register somewhere. The same with if you want to be a maintainer of the feed or produce your own new tasks, you don't have to make some accounts on our website or something else. You just need to get tokens and stake them in our storages on our deposits. That's all you need to register. And the same with consumers. Consumers of data need only some payer that will pay tokens for this contract, so that will allow the contract to pay for itself. And that's all. All entities are working with each other in a decentralized way. Now we want to present you the web part of our submission. A web part of our submission is a web service, web-free service that you can check. All our links are in submission. Here in this service, you can the whole purpose of this service is to control your account. So you can manage your account funds. For example, currently I don't have account, and I can't receive responses from Oracle. I can't create my own tasks, but I can do this if I start my own account. Okay, our project have full cycle ecosystem that is based on our own CHIP3 token. To get this CHIP3 token, you can use our token facet. To use this, firstly copy a token address on the site. You can do this here, copy it, then add to your Venom wallet. I already queried some tokens. If you click the token facet button and approve the transaction, with a Venom wallet, then you can query some more. Okay. So if we look in our wallet, okay, we have more tokens. Now to start using system, you can deposit Venoms and tokens. I'll show Venoms. Okay, we deposited 2 Venoms. Let's wait until they go to storage. Here we are, we have storage. Now, when when you deposited some Venoms or tokens, you can go to Task Studio. Task Studio is our best feature. It is easy to use constructor that provides you an ability to make tasks your own. For example, let's name our task. Our task will be as USD price, for example. Now we can choose a consensus to make. Consensus currently we support 2 types of consensus. It's exact match, means that all validators that provides answers should provide exact same answer. If answer differs, then this validator provided bad answer and it can be slashed. And the medianized consensus, this means that a response will be taken as median from all answers, and as it's median, then your task should end with some number, some integer value, so it can be medianized. Next, we can choose a trigger for execution. We have 3 types of triggers currently. First type of trigger is on request, means that when you query your task from consumer, an immediate new consensus will be made, and all of validators will requery their responses and a response to you. Second is on schedule. It means that validators will not immediately answer, they will answer by schedule, and you should have enough deposit, so each schedule execution will spend some money from your account. And the data feed, this means that this task will be constantly have responses, and if you query it, you will receive a last response immediate, and these responses will change based on deviation thresholds. For example, if some time passed, or if value differs from previous. Next, you can specify actions. Let's make first a very simple task, exact match on request. Still we then what we can do now, we can make our task from action blocks. We can choose every action that this task will make. For example, let's use first action. This action is called HTTP request, means that it will query some HTTP, some URL, and let's add this URL. Let's run it. It says to us that we didn't specify that this is final action of a task. Let's specify it. Okay, verify. Okay, it verified. We try to run it, and we see the response from HTTP, but this response is JSON. this is not good. We don't need JSON, so we need to somehow parse it. Let's parse it. 1 minute. Okay, let's parse it. To parse it, we can use parser action that is called JSON value. Okay. Okay, now let's add some JSON value. This means that we will parse HTTP answer. How to do this? First, we'll add pass. It means that we'll get a last tag from response. So how to get it from previous response? Just drag and drop to body. Okay, we drag and drop to body. So now this is final action. We'll verify, and we see a price from our previous HTTP request. This way we can construct any actions that we want, any tasks. We have some actions, mostly at mathematical operations, parsing, requests, TVMCL encode decode for native Venom types of data, and so on. When you're fine with your task, you can download it. If you click download, you'll receive JSON representation. If you like it, you can then add it to task contract manually and deploy it yourself. Or if you're happy now, you want to deploy, you can click deploy button, and with sending transaction you will deploy it. Also, you can upload an already made task by using import feature. Let's upload already made JSON. Okay, it's uploaded. Now we have parsed actions from JSON, and you can check it, run it. Okay, this task, by the way, uses median function from different sources, so we can use already medianized answer. What I want to show you next is how to connect your own contracts as a consumer. Next, I want to show you how to make your own consumers, how to use Oracle in your contracts. Go to our GitHub submission. Here you can find connected contract chapter. Firstly, you need to import two files. You can find here both of them. Next, you should implement them, implement consumer interface, and implement two methods. First, that request the response from the feed, and second is callback that accepts responses. Also, here you can find the place where you can insert your own logic. Here's the architecture of our contracts. In our contracts, there is a consumer. Consumer is an entity that want to receive some request from Oracle. Usually it's a smart contract or a smart service that uses smart contracts. Such data can be prices, can be some forecasts, randomness, and other things that contracts usually want to acquire from external data. To achieve this, we made a system where you can use your contracts, and in the same time your contract doesn't paying for execution. You can choose a payer that pays, and this payer is making allowance to consumer contract, and with this allowance when it queries the task feed in our system is a contract of some tasks that you need Oracle to do. For example, calculate feeds or request something, and so on. So consumer contract queries the task feed, and task feed checks that your consumer contract has allowance to spend money, and takes its money to itself to spend this fee to validators. Then, when payment is approved, task feed spawns an event. Event is external message that is listened by validator nodes. Currently, we placed in our example app 4 validators that are listening to events and subscriptions. And when they see some new requests to task feeds, they execute this request and produce an answer. As this answer is good, if all conditions are met, then this answer will be sent to consumer contract, and validators will receive parts of the fee that was paid. That's how a request task works. The other type of tasks are feeds. Feeds are tasks that are constantly producing responses. For example, if you query such feed, you'll receive your response immediately after paying. And validators are monitoring these feeds to check if some deviation happened. For example, Ethereum USD price is deviated from a previous value, and it needs to be requeried, and new consensus should be done. This is how our architecture works. Next, our tech stack. We use a lot of our own products in our tech stack. Our product is based on Ever SDK and our own binding and framework around it, made for Java language, and on base of that, we produced a new validator node that works concurrently with our requests using virtual trust technology of JDK 19. And this validator node executes our requests. Also, we have web part. Web part is made using TypeScript, a lead framework, and Hilo framework. And this all. Okay, thanks to everyone who watched this. Thanks for attention, and to judges of Venom Hackathon. Thanks for a great hackathon, and meet you next time. Bye bye.